Particle motion part 2. This time I want to talk about distance. So we have the position of our particle is given by this function, and I want you to be really careful about the idea that sometimes they're going to give you the velocity function instead of the position function. So in this case, I'm telling you now that we have this position function of s of t is equal to t squared minus t, and this is for t is greater than or equal to 0. S is in feet, t is in seconds, and no calculators allowed. So find the total distance. Well, just keep in mind this is what we have. We have this little particle thing. Maybe our particle today is a mouse. Sorry, that's my mouse. Yeah. Anyway, and he's running back and forth. And the question is, how far does he run total? But if you think about it this way, we don't know for sure that he runs this direction, right? So I want to know, find the total distance traveled in 2 seconds. So what you could do, I guess, is you could say, well, what's his beginning position? So where is he at s of 0? And we take this function here, and we take 0 squared minus 0 is equal to 0. So he starts at 0. And then we could, I guess, say, well, where is he at s of 2? And at s of 2, he's at 2 squared minus 2, which is equal to 4 minus 2, which is equal to 2. And so it might seem to us that the total distance traveled is 2. But what if he changed directions? What if he ran this way for a little while, and then he ran back this way? Well, we'd have to count all this distance that he scrambled back and forth, and that's where we come into something here. So first thing I want to know is, when does he change direction? So to answer the question, when does he change direction, we'd have to figure out what the velocity is. Why? Because velocity can't switch directions without going to 0. So let's take this position function. Let's try to find the velocity function, and we know that velocity is the first derivative of position. So taking the derivative of this now, so that's 2t minus 1. So when velocity is 0, he's changing direction, right? So we have 2t minus 1 is equal to 0 when his velocity comes to a complete stop. We solve this out, and we find out that at t equals 1/2 second, his velocity changes. So I guess now the point is, we know this point here, we know this point here. We need to know what happens. Where is he when he changes direction? So we're going to take s of 1/2. And s of 1/2 is 1/2 squared minus 1/2, right? I'm just using the position, which is 1/4 minus 2/4 is equal to negative 1/4. So we're going to go up here, and we can say our little guy started right here at 0. Here's our mouse. Why can't I draw a mouse? That's a mouse, I swear it is. There's our mouse. And what we know is, for the first half second, he ran that way, and he ended up at negative 1/4. He only, right, he changed direction here, right? So he went from here to here, so, right? So then we have s of 2 is 2. So he ran this way for a total distance, right? Total distance is equal to, right, I know he's at negative 1/4, but that's a distance of 1/4, isn't it? Plus, he ran from, right, then he, at 1/2 second, he's here, and he runs all the way back to 2, doesn't he? And what's that total distance? Well, the distance from negative 1/4 to 0 is 1/4 plus getting to 2, so it's, right, it's 2 1/4, so 2 1/4. Total distance traveled, 2 1/2 feet. All right, hope this was helpful. I'm going to see it on the AP exam.